Hello, my name is Robert Smith, and I'm with New River Community College's Academic Assistance, and today we are looking at the periodic classification of elements. So we're told that a certain atom has 16 electrons. What is its ground state electron configuration of the element? And how should it be classified? And is the element diamagnetic or paramagnetic? So these are three relatively easy questions. And we don't even need a periodic table to see this, to do most of this. So let's start with the first part. What is its ground state electron configuration? So we know that there are 16 electrons, as it says right here. So all we need to do is count to 16 and know the order in which the electron configuration occurs. 1s, 2s, 2p, 3s, 3p, and so on. So for, let's say, part A, we're going to do 1s2, because you can only have a maximum of 2 electrons in the s orbitals. 2s2, so that's 4 electrons total. 2p6, that makes 10 electrons. 3s2, that's 12 electrons. And 3p4, that gets us to 16 electrons, because 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 4 is 16. So that one was relatively easy to do. So the other thing to look at is it is asking us how it should be classified. Now, there are several ways in which elements can be classified, but one of the most commonly used is whether or not it's representative. And because our 3p orbital is not completely full, it would be a representative atom. And that means that it's over in this area right here. And in fact, our atom, if you noticed, is sulfur. So we'll just climb back up here and put part B. It's representative. And the definition of representative you can find in your book. It's not very complicated to identify which elements are representative versus which elements are transition elements, so transition metals, and so on. You could also say that it's a nonmetal if you wanted to classify it even further. Because it's in the nonmetal category, it's sulfur. Sulfur is not a metal. And the last question asks if it's diamagnetic or paramagnetic. Now, the easiest way to look at that is whether, basically we have to set up our orbital. So if we were looking at the last bit, the 3p4, we're looking at 1, 2, 3, and this is 3p. And this would be 3px, 3py, and 3pz. Okay? So let's count this off. We've got 1, 2, 3, and 4. And because we have unpaired electrons, which would be over here and here, we would generally call this a paramagnetic element. So, therefore, it is paramagnetic. If the electrons had been completely paired off and we had basically everything was full up, then we would call it diamagnetic. Okay. And that's all there is to this question. That's all there is to periodic classification of the elements. just need to read through the chapter and analyze the material, go through it piece by piece. This whole chapter is more knowledge-based than it is quantitative. So it's a little different than pretty much every chapter that you've encountered thus far. So it's going to be a lot of knowing definitions of things and being able to identify where those definitions apply. So I encourage you to read the chapter thoroughly, especially the points where they have vocabulary words like paramagnetic, like diamagnetic, and as well as trends in the periodic table, because that is going to be the biggest component that you're going to be quizzed on and examined on, is going to be the trends in the periodic table, which we will discuss in future videos.